In the previous video, we have learned about hydraulic system where you apply a small force at X and it allows you to amplify the force at Y. And in our real world, beside the hydraulic system, in general, they also have a lever system, or from the topic on turning effect of force. As you can see here, this lever system allows you to apply a small force, 50 Newton here, and you will achieve a much greater force at force X before it's applied to the hydraulic system. Without further ado, let's solve for Fy, the output force, and let's start with the lever system. It is very obvious that the Fp 50 Newton that's applied on the handle here will create a anti-clockwise moment about the pivot. But for Fx, students are confused because as you apply a force of 50 Newton downwards here, this handle is going to go down and this piston at X will actually go down. And students think that the force Fx here is also creating anti-clockwise, which is wrong. You have to understand that we are more concerned with the force acting on the handle. So Fp is downwards creating anti-clockwise, yes, and the handle is pushing the piston rod here downwards, and because of action reaction, Newton's third law, there's an equal and opposite force Fx that's acting on the handle. So this Fx is the same Fx, same in magnitude, is actually creating clockwise moment about the pivot point. So that's very important. And to solve for Fx, we will be applying principle of moment, where the anti-clockwise moment due to Fp is equals to the clockwise moment due to Fx. So under anti-clockwise, that will be your Fp times the distance p is equals to your Fx times the distance x, and Fp is 50 Newton, and the perpendicular distance from Fp all the way to the pivot, so it's a total of 120 cm times Fx, which is the unknown, times the perpendicular distance from Fx to the pivot, which is just 20. So Fx will be 300 Newton. So you can see that the lever system is able to amplify the 50 Newton by 6 times to 300 Newton. Next, let's go to the hydraulic system. So it will be pressure at point X equals to pressure at point Y, and the force at X equals to area X, force at Y, the unknown, over area of Y. So if you were to sub in the value, Fx is 300, which you have found here, over the cross-sectional area 2, Fy over the cross-sectional area is 10, and you can find that the output force will now be 1500 Newton. So you can see the output Fy is 1500 Newton, which is 30 times the input force of 50 Newton at Fp. In the previous video, we have learned how to explain why Fy is greater than Fx for the hydraulic system. But for the lever system, the way to explain is actually similar, just using principle of moment. So since the anti-clockwise moment due to Fp is equals to the clockwise moment due to Fx, and since moment is force times distance and both sides are the same, so since the perpendicular distance dp is much greater than the perpendicular distance of force x at dx, therefore the force at x has to be greater than the force at p. So just use the relationship to help you to explain. Before we end off the video, let's talk about cross-sectional area. There are questions where they don't give you the area directly, but instead they give you the radius. For example, the piston X has a radius of r and piston Y has a radius which is 3 times larger. Now take note of this. So the area of Y is not equals to 3 times the area of X. That's very important. So how do we find the area of Y? So this is 3 times the radius versus X, which is just r. Let's recall the formula for area of a circle, pi r square, and let's assume this is area of X, where the r is the radius. So if we are going to look for the area of Y, that will be pi radius square, and the radius now is 3 times the r and the whole thing square. And if you work it out, that will be 9 pi r square. And I will going to sub pi r square with ax. So this is 9 times the area of X. So the area actually increases by 9 times, not 3 times. So it's because of the square, not times 2. So I hope you remember that. So I hope with these 2 videos on hydraulic system, you'll be able to solve most of the questions regarding hydraulic. So thank you.